49. Okay, so what we have to do on the next couple is determine the sum, if any, for the infinite series. Okay, infinite meaning it's going to go on forever. Like I noticed this ellipse here, meaning it's going to keep going and going and going. So it's just going to go on to infinity. Okay, so I have to think to myself, well, what kind of pattern is this? I know we've talked about geometric patterns, we've talked about arithmetic patterns. What is this one doing? And as you take a look down this list, it is multiplying by 1/3. Now, some of you might be thinking it's dividing by 3, right? But when you are figuring out patterns with multiplying, you always want to think of it in terms of multiplication. So here's a little trick. If you see that it's dividing by 2, it means it's times 1/2. If you see that it's dividing by 3, it's times 1/3. If it's dividing by 4, right, it's times 1/4. Think about it, because if you're going to multiply something, you'd want to be dividing by this number on the bottom, right? And that's what your division is. So there's a little trick. If you can't figure out what it's multiplying by, think what is it dividing by, and just drop that number down into the denominator. Okay, so now that I know that my rate is 1/3, this is actually one that you do get a formula for, and the formula looks like this. First term over 1 minus r. But your rate has to be, the absolute value of your rate has to be less than 1. So basically we're looking for a fraction that's less than 1 that's like positive or negative. So it doesn't really matter if it's positive or negative. It just has to be a fraction that's less than 1. So, think back to middle school. The bottom number has to be bigger than the top number, and that's kind of your general thumb. Okay, so in this problem, I see that the first term is 9, and 1 minus 1/3, right? That's my rate. So this will give me my sum. Okay, so let's go ahead and clean this up. What I think I'm going to do is change this 1 here to 3/3. It just makes it a lot easier for me to subtract. And this is where a lot of students get stuck. 9 divided by 2/3, especially without a calculator. As you can see, this is a non-calculator question. What we're going to do is we're going to multiply the numerator by the reciprocal of the denominator. So this guy's going to get flipped. So we have called it keep, change, flip, right? Keep the numerator, change to multiplication, and then we're going to flip over or do the reciprocal of your denominator. From here, I'll put the 9 over 1, and I'll see if there's any cross-simplifying that I can do, but it doesn't look like there is. So 27 over 2 will be my infinite sum. If you think about it, it makes sense because I keep adding numbers that are getting smaller and smaller and smaller and smaller. So finally I'm adding numbers that are so tiny, it's just going to be negligible. So this number right here, this 27 over 2, is going to be like at infinity, basically its limit. Where is it going to try to get to? Okay, on this one, let's take a look. My rate in this problem is 2. Right? Your rate is going to be what it's raised to the power, like what number is being raised to a power. And in this case, it does not meet the rule, right? It's supposed to be, the rate is supposed to be less than 1 if it has an infinite sum. So if you started evaluating numbers here, right, plugging in 1, plugging in 2, plugging in 3, plugging in 4, the numbers are going to keep getting bigger and bigger and bigger and bigger. It's going to be impossible for you to add these up. This is what we call it diverges. So this has no sum exists. Okay, for 52, we are going to find the sum, right? And you can see it's the summation notation from 1 to 4, terms 1 to 4 in the function 3n plus 1. So there are, I'm sure there's lots of ways to do this, but kind of the two ways that we've talked about are you can either, and again, you notice without a calculator, you can either plug in 1, plug in 2, plug in 3, plug in 4, get those numbers, add them up, move on, okay? Or we did learn a formula for adding patterns. I can tell it's an adding pattern. This is a power of 1, it's just like a linear, it looks like 3n plus 1, it looks like a straight line, form of a straight line. So the formula for it would be the number of terms times the average of your first and last term. You could find the first term you're looking for, the last term you're looking for, divide them by 2, and multiply by how many numbers you have. So there's a formula. You're not provided with that formula, but it's a pretty quick and easy way to figure it out, and it's a little bit less work, especially without a calculator. But it's totally up to you. We only have to evaluate 4 terms here, so it's not so bad. Okay, but either way, I need to know a couple of things. I need to know how many terms are there. Well, we're using 1, 2, 3, and 4. So 4 terms, right? This is where you stop. This is where you start. No matter what, I need to go find the first term, right? So we're going to go plug in 1. 3 times 1 plus 1 is 4. We also need to go find the last term. And in this case, again, we're stopping at term 4. So I need to plug in 1, and then now I need to plug in 4. 3 times 4, 13. So if you want to use the sum formula, if you've memorized it, okay, I get 17 over 2. And then that's a little bit yucky. That's going to give me a decimal, so I think I might cross simplify here. And then 34. So there's my sum. Now, another way you could go about this, and a couple of you guys did this on your quiz, was you just went out and found each term. So we could still just go find A2 and A3. 3 times 2 plus 1. 3 times 3 plus 1. What's that? 10 and 7? And you could literally just go and add up these numbers, and you should still end up with 34. So a couple different ways to do it. It just depends on your preference and how many terms. If I asked you to do 15 terms, that might not be faster. Here's 53. So same thing. On this one, we just have to be careful because we're starting with term 5 and ending with term 10. Okay, so you're going from term 5 to term 10. So if you want to use the rule, first let's figure out how many terms that is. Notice I didn't put a 1 here this time because actually we're looking for term 5. So it's actually 5 to 10 is actually what we're looking for. But be careful with the end. This one's tricky. A lot of students will say that it's 5 terms. But actually we're using 5, 6, 7, 8, 9, and 10. Look, 3 and 3. This is actually 6 terms. So be careful. If you subtract, make sure you add 1. You're using both the 5 and the 10, not just finding the number of jumps between them. Okay, so to find the 5th term, we would say 4 times 5. And to find the 10th term, we're going to do 4 times 10. And then we can plug it into the formula. I might cross simplify here just to make it a little easier without a calculator. And then 380. Okay, now if you want to go back and do it kind of the longer way, you can go evaluate 6, 7, 8, and 9, and then add up all those terms, and you should end up in the same place. Okay, I'm going to stop here because this one's probably a little